In the next part of chapter 4, we are going to see 4.5 metallic bond. Okay, what is metallic bond and electrostatic force between positive metallic ions and the sea of delocalized valence electrons? The metallic bond can be imagined as an array of positively charged ions immersed in a sea of delocalized valence electron. In the solid state, metal atoms are closely packed in regular arrangement. The solid lattice held together by a strong electrostatic force between the delocalized electrons and the positive ions. For example, we look at this model. This model is called C electron C model. Dikenali sebagai electron C model. And when you want to explain the metallic bond, you have to explain about electron C model. First, you have to draw a box and then you place positive ions, maybe 4 times 3 or 3 times 3. At least the 3 times 3 is the minimum. And then you have to draw electrons. Students can see the alphabet small case E there. That represents electron. So positive ions are immersed in the sea of electrons. So we imagine the electrons like a sea, and then the positive ions immerse inside the sea of electrons. And these electrons are called delocalized electrons or free moving electrons. So the attraction between the positive ion and the negatively charged electron is known as metallic bond. So I repeat again, when you want to explain about metallic bond, apart from these points, you have to draw electron C model. Okay, properties of metals. Metals have the following physical properties. You have learned this one in your upper secondary school: malleability, ductility, electrical conductivity, and thermal conductivity. Malleability can be pressed into different shapes. Ductiles can be pulled into wire. Metal atoms are arranged closely packed. When sufficient force is applied to the metal, one layer of atom can slide over one another without disrupting the metallic bonding. As a result, metals are malleable and can be drawn into wires ductile. So this is due to the arrangement of atoms. Most importantly, point number two, the layers of atom can slide over one another without disrupting the metallic bonding. That means they can be malleable and ductile. Next is electrical and thermal conductivity. Metals have high electrical and thermal conductivity because of the sea of delocalized electrons are free to move from one end to another end when there are differences in electrical potential or heat. The free moving electrons or the delocalized electron causes metals to have electricity and also thermal conductivity. Sorry, electrical conductivity and thermal conductivity. Okay, now we look at the factors that affect the strength of metallic bond. There are two factors. One is size of positive metal ions. Second is number of valence electron. The strength of metallic bond is proportional to number of valence electron, meaning to say more valence electron, higher the strength of metallic bond, and inversely proportional to the size of atom. Smaller the size of the positive ions or the atom, the strength of metallic bond will be higher. The smaller size of positive metal ions and the more number of valence electron will exert stronger attraction of metallic bond. Effect of strength of metallic bond on boiling point. Boiling point of a metal depends on the strength of metallic bond. The stronger the metallic bond, the higher the boiling point because high energy is required to overcome these strong electrostatic forces between positive ions and the delocalized valence electron in metallic bond. So we must remember the first point, boiling point of metal depends on the strength of metallic bond, whereas strength of metallic bond depends on the size of positive ions and number of valence electron. So these are very much interlinked ideas. So for example, we have magnesium and aluminium. We can see aluminium obviously greater than magnesium. What is the reason? Aluminium higher than magnesium because the strength of metallic bond in aluminium greater than magnesium because aluminium has 3 valence electron and smaller cationic radius while magnesium only have 2 valence electron and larger cationic radius. Thus, our conclusion, strength of metallic bond directly proportional to the boiling point. The stronger the boiling point, the stronger the metallic bond, the higher the boiling point. We then we end chapter 4.